question, right? So you're probably all wondering what was the question that Steve got asked that was completely unanswerable. Well, it was how long would it take to rebuild production? So kind of roll back a little bit. I'm at a bank. They've acquired me. I'm now leading a small team of people, and roll kind of on maybe like 3 or 4 weeks. I've apparently had enough time to get familiar with what's going on. And they said to me, so, we want to be able to rebuild production because we're really worried that it's going to go down. Can you give me an answer of, how long it's going to take? So this was me at home. I have no idea, right? There's so many different moving pieces to this puzzle. How can I possibly answer how long it's going to take to rebuild a platform? I've genuinely got no idea. Why did I have no idea? Well, the first reason is because of this. So everything was ticket driven. There was a dedicated member of the team that was inside of platform engineering, and you had to write a Jira ticket, and if you didn't write a Jira ticket, you weren't going to get the work done. And if a developer asked him or her for a Jira ticket, that was less important than his or her Jira ticket, so it never actually got done. Sound familiar? Then everything was kind of ClickOps, right? So they just go into the console and start clicking things, and developers would create buckets, and then EBS volumes, and then there was an RDS database that had hundreds and hundreds of gigabytes of RAM that no one was really using. And the bill was ballooning out of control. And then we had this kind of slow release process. So because everything was ClickOps, nothing was the same. So we ended up deploying to staging and expecting it to work, and then by the time we got to production, production looks nothing like staging. So we ended up in this situation whereby there was absolutely kind of a lack of confidence of what was going to be rolled out. Then it was this, right? And talking with what Derek was talking about earlier was really that the platform engineers were just constantly fighting with the developers. The Jira tickets definitely didn't help, but there was a lack of communication, and there was 2 siloed sets of people. There were the platform engineers that built the platform, and then there were all the developers. And the developers hated the platform engineers because the platform engineers wouldn't do anything that the developers wanted, right? And then you ended up with this tug of war. So everything that was wrong and the reason why they couldn't release was a platform engineering problem. And platform engineering didn't have the ability to be able to give them the answers of actually we aren't the problem, because it turns out they were the problem. Then we had this problem. So hands up who calls it control for kubectl, kubectl control, kubectl cuddle, kubectl cuddle. So they were using Kubernetes, but they didn't have the people that had the Kubernetes skill set. They didn't have them, right? They were just dumped with Kubernetes and kind of said, just get on with it. Just deploy your workloads to Kubernetes, and we'll figure it out. I've been to a meetup and someone told me that Kubernetes is the next best thing, so let's get it in production and it's going to solve all the problems. But you actually need to help the developers and meet them halfway, right? Once we've met them halfway, we have the ability to be able to help them, and they become ambassadors of the platform that you're currently building, right? And once you've got ambassadors, those developers talk to the developers in a different team, and everything starts to work a little bit more smoothly, and there's less kind of platform engineering of the bad people, they won't let me do anything. And then we've kind of covered this already, but changes were extremely risky. We talked about staging being different from production. So you got some kind of level of confidence when you're running in your kind of downstream environments, but when you got to the production ones, it was like this. And I was this guy a couple of times, but I was actually underneath a desk because we were doing some stuff with invoicing and displaying people's bank balances. And someone decided that they were going to roll something out on a Friday at lunchtime because they thought it was a good idea because no one's going to be browsing the application, or their mobile application on a Friday. Well, it turns out that was when everyone was needing to submit all their stuff to HMRC, and I was extremely worried that this wasn't going to work. Turns out it didn't, and this is me actually leaving the office on the day that it happened. Thankfully, I actually did go back, but that taught us an interesting lesson. Right, and if we can take lessons and turn them into valuable output, that's a benefit to the organization. Granted, they lost a little bit of money, but let's just kind of gloss over that a little bit. This was me. So I had to sit there. Steve, you're the consultant. You're the one that we've brought in. Like, explain yourself. Why do things keep falling over? Why do we keep having all these issues? Why do developers keep moaning about platform engineers, and why do platform engineers never talk to developers? Well, this is a big problem, right? Confidence is contagious, but so is the lack of confidence. No one had any confidence in the platform engineering team at all, period, nobody. From the CTO all the way down to the most junior developer, they got blamed for absolutely everything. They were the problem, no one else was the problem. get out of our way and we'll be able to continue and move faster. So then I was sat there having to explain myself and try and come up with all of this nonsense reason why, why I couldn't give you an answer and why everything was going wrong. And then someone just came up to me and said, fix it. Fix all the problems. I don't care how long it takes. I don't care how much money it's going to cost you. Just fix all the problems. They were lying about the money piece, and we'll kind of get to that in a little bit, but fix all the problems. This is me. Cool, yeah, no problem. I'll figure something out. This was actually me. I just wanted to go on. I had absolutely no idea how we were going to fix all these problems. I was just like, we'll just blag our way through it. And I think you asked an interesting question earlier about how you get people to kind of embrace and empower what you're doing. So one of the things that we did is we set up a KET, a Kubernetes enablement team. And that was a team of individuals from different areas of the organization. So we had some security people, we had some network people, we had some database people. The list kind of grows. We even had HR in there as well. And those people were responsible for driving the change that we were going to make. Right? If we built a platform without the developers getting anywhere near it, damn right we're going to build the wrong one. Right? But if the developers had an impact and a say in what we were building, then they could only really blame themselves, or they would continue to blame platform engineering, but they could also blame the other people in the enablement team as well. So what we did is we started with an enablement team, and we drove everything from this core set of people. So building a platform is kind of perfect-ish. If you're familiar with Sagrada Familia, this thing's taken about 100 years to build, and it's still being built. It's absolutely spectacular inside and out, but it's never finished, right? It's basically every platform going, everyone thinks their platform is absolutely marvelous, but they still have to build and add more features and more things to it. So, what did I do day one when I got the Kubernetes enablement team? Well, it all starts with a strong mission statement. If you've got a strong mission statement, you can convince absolutely anybody to do anything, as long as you've got a bunch of buzzwords in there that they're going to agree with. So we started with this mission statement. Loads of buzzwords. So we're going to provide an easily extensible, don't really know how we're going to do that. Config driven, I've got a little bit of an idea about how I'm going to do that because I'm an engineer, right? Ephemeral platform, well, the word ephemeral to them sounds absolutely fantastic, so we're already onto a winner. Clear ownership, well, I don't want platform engineering to be the ones that get moaned by developers. So once we've got this ownership model sorted out, there's really nothing that anyone could say. And then we added this little bit at the end that says, most importantly, reliable and consistent, because that's the bit they really cared about. All the other two bits were a little bit fluffy. They really latched onto that bottom bit. That's the bit that they really wanted. So let's start with the easily extensible and config driven part. So we had to start with a base platform. And we're running in AWS, and then we wanted to put Kubernetes on top. It's a Kubernetes meetup, so I thought I should at least have one slide that says Kubernetes in it. And then on top of that, we wanted to deploy the workloads, whatever they were. I didn't know what they were. There was documentation all over the place. There was Confluence pages. It was a whole thing. But there was a bunch of workloads. So we started with the infrastructure and we used Terraform. Whether that was a good choice now, looking back, questionable. But we had a dedicated repository for all modules. So because if you remember previously, I said all the challenges were that they just ClickOps to everything. No one knew what the hell was being built. Like there was just random stuff all over the place. So what we did is we worked with the platform engineering team specifically and started to create this dedicated set of modules. And then we had a number of what we call Terraform routes. So routes are really executed modules. So imagine, to Derek's point when he was talking about promises and he had a bucket in an application, think of kind of a dedicated Terraform route as two Terraform modules kind of joined together that will deploy to do something. That may be a bucket in a database, that may be a database and a load balancer, who knows. And this was our lovely repository of Terraform modules here that we worked through. But the routes specifically, if you notice, if this is going to work, no, the laser's not going to work. At the top, you can see there we've got a bucket definition. We've got a bucket definition that says the word platform engineering. Or if you're not in platform engineering and you're in an application team, you get your own bucket, right? You can go and break your own stuff, but don't come anywhere near mine and break mine, right? Because we like to point fingers, right? They like to point fingers at us when we were the problem, so we're going to point fingers back at them when they break their own things. But you'll notice, if you were eagle-eyed, that there was a couple of modules that had the word application in, right? So this was when we worked with the application team to define certain types of components that they would leverage regularly and need in order to be able to deploy their workloads. if we can make this our contract in which we talk to them from, and they are bought into this contract in terms of the specification and what it looks like, and they only need to set a couple of fields and a couple of variables, then we're on to a winner. So here's an example. You can see at the top there, we've got an application S3 bucket, we've got a reference to it, there's some application name, you specify the platform and you specify the team, right? You don't need to know about anything else. The fact that it's versioned, the fact that some of the storage is going to Glacier, no one needs to know, right? This is just the contract in which we define. Once they have the understanding of this, it's kind of rinse and repeat and we get out of their way. They can deploy their own Terraform, they can deploy their own infrastructure, and platform engineering can continue doing what platform engineering needs to be doing. So how do we make that part developer friendly? Well, it's really about, and Derek actually stole my thunder here a little bit, so it's really about doing everything via pull request. So when we do everything via pull request, we have the ability to have some kind of control. So the developers have the control, but we have these kind of guardrails that stop you from doing anything a little bit silly, like setting the database memory to, like hundreds and hundreds of gigabytes when you don't need it. So here you can see someone's opened a pull request. Atlantis has kind of done a plan. So we're going to tell you what you're going to be creating. And then someone has to approve that, or multiple people have to approve that. And then you type Atlantis apply, and lo and behold, everything gets deployed, right? Sounds absolutely marvelous. Pull request merges, we've got everything audited. When the auditor comes, what changes did you make? Very easy, we just go to Git and we pull all the pull requests. But one of the things working in finance that you have to do is you have to keep the compliance posture high, right? So we have to make sure that we are compliant to certain types of standards, and how are we going to do that in an easy and efficient way? Well, that's really by using this tool called Regular. And what Regular allows us to do is it puts policy in the middle. So you run the plan, we run the policy suite essentially against the changes that you're making. You fail, you don't get to do it. You pass, you then get the ability to be able to apply it, right? And that's where kind of security kind of sat in the way and said, they love saying no, right? So this was the kind of no barrier of you actually being able to make changes. So now how do we define clear ownership? And this is really what the majority of the talk is about. So it's about GitOps and using Git to drive changes. So Derek again was talking about Flux. Flux is going to be heavily used in this next couple of moments that we're going to talk about here. So this was my life in general, right? I started off as a developer on the right-hand side, and then as a platform engineer, I was kind of checking this thing out called GitOps, because I was like, oh, we can drive everything from Git. Every developer loves Git. Let's just put everything in Git. What could possibly go wrong? So hands up for people who are familiar with GitOps and what I mean by GitOps. Okay, the majority of you, right? So we're not going to do any like YOLO, just deploy random workloads to the cluster or do a Helm upgrade. We're not going to do any of that. We're going to drive it from Git merges. So that same pull request that we were doing for infrastructure, we're going to do the same pull request for anything we deploy to Kubernetes, whether that be a secret, whether that be a specific workload, whether that be network policies that the network engineers want to put in. We're going to drive everything via Git. So another audience participation is, what is your GitOps tool of choice? So there's a bunch here, there's absolutely loads, but I did the ones that I was hoping most people would be familiar with. Jenkins X, strong. Jenkins X is winning. Interesting. Oh, other. Okay. Cool. So obviously, yeah, some of you are using GitOps tooling, which is great. I have a love-hate relationship with Jenkins X. If you want to know why, come and talk to me afterwards. So we're going to talk about Flux. Flux is what we decided to use for our GitOps tool when we were on this client site. So Flux is broken down into a number of different controllers. You'll see the source controller there that takes information from multiple different sources, whether that be your Docker registry, whether that be your Git repository, or whether even if you're crazy, you can put it in S3 if you wanted to. Then you've got your customized controller, hands up for people that are familiar with customized and what I'm talking about. Okay, so customized kind of allows you to be able to blend this concept of like a base and a patch. So you can put the majority of your configuration in your base and then have kind of sandbox or development patches where you're specifying the number of replicas that you want. you've got a Helm controller, pretty self-explanatory, and then you've got a notification controller that kind of fires all these things to Slack and name any other tool that you might be using. So how are the repos structured, right? Because we had all of these different teams that weren't talking to each other. But if we could sort this out, we could kind of sort out the majority of the problems if we structure this well enough. So we started with the obvious, right? The K8 releases platform, which was all the platform engineering workloads. So think things like Grafana, think Prometheus, think all of the logging stack. We kind of got all that into one centralized location. And we were using Customize here. You can see that we have a customized directory, and then inside the customized directory, we have a number of different directories. So we've got the base directory, which is the majority of the config, and then we have the folders underneath, which are specific to the clusters that you're deploying into. Regions there because we had multiple regions. So this repository was split into two. So we had cluster resources, which is kind of all of the stuff that no one really cares about that's actually quite important, such as role-based access control of how people actually access your Kubernetes cluster. Down to storage classes, because people need to create volumes because they want to store stuff locally to the running workload to be able to leverage it. We were in control of this, right? We weren't in control of every single one of your namespaces, but there was things inside of namespaces that we wanted to be able to set, such as quotas, right? We don't want people to be able to consume hundreds and hundreds of gigabytes of memory and loads of CPU when we clearly don't have that at our disposal. Then we had components. Again, I've already talked about these. We had these broken down into the versions. Why did we do that? So that we could have a centralized way of managing versions of different tools between different environments. So maybe in staging, we were running Alert Manager 0.25, but maybe in production, because we were crazy, we wanted to decide we were going to upgrade that to 0.27. And it was really obvious when you look at this, how this is coming together, right? We wanted it to be in such a way that if a developer needed to make a change or wanted to propose or suggest a change to running a new version of a tool, they felt empowered to come here and do it, right? The easier we can make this, the easier we make everybody's lives. So then in the base configuration, as an example, we've got 9.4.7 here, and you can see that we've specified the tag down the bottom there of 9.4.7. So the base configuration has the majority of the changes. The patches are going to be tiny. If your patches are massive, then there's something wrong, and we probably need to abstract it and put more in the base configuration. So here's an example of the sandbox patch. It's just the sandbox specific config, which is actually just all of the host names that you need to be able to browse to the application. The easier we make this, the next time we need to add a new environment, it becomes very easy. We just kind of clone the base to a new directory and make a bunch of changes, and then everything, fingers crossed, touch wood, just works. Then in the customization, we obviously we say at the top there where it says resources, we're going to include everything from the base component. So we're going to take the whole entire lot, and then we're going to do a strategic merge, and we're just going to take that Grafana patch that you care about. So you're going to get all of that Grafana config plus the host names that we added at the patch. This is a controversial one. So how are we going to do secrets, right? So we leveraged SOPs. Hands up people who are familiar with Mozilla SOPs have used it before. So SOPs just allows us to be able to encrypt secrets and store them in Git. That raised a lot of eyebrows with certain members of the organization in the bank. But what we realized is that everyone was doing secrets differently because people needed secrets to run their application. Some of them had them on the box in CI, which was just crazy to me, but anyway. If we needed to make secrets consistent, right? Because if these leak and get out of hand, we start to get a load of problems. So if we could combine everything into one location and we could have one single directory where we're managing secrets, everyone goes to the same place to make the same set of changes. So again, similar structure here. Instead of saying customize now, we say secrets, fourth directory down there. Same directory structure again for the different clusters that we have, right? This is hopefully becoming really, really boring because it's supposed to be boring in order from the structure perspective. Then we have a SOPs file that essentially says what KMS key and what ARM do we want to use when we encrypt the secrets. We then encrypt them into Git, and then when they get sunk to the Kubernetes cluster, Flux knows which which roll on and roll to assume, decrypts them, and actually turns them into normal Kubernetes secrets that you can use. So we stored everything, all the secrets in Git there. This is an encrypted secret, a little bit too small, but essentially the section here says what ARN and what role are you using to encrypt. This is the encrypted token which you can't read, and then this is the normal secret as you're familiar with. So the whole idea there was that we were keeping the same pattern and storing everything in Git. At the top there, this is a Flux configuration. We have the Git repository. We specify the branch that we want to pull and the URL of the Git repository, and then below is the customization. And here is all you really need to do to tell Flux that you want to use SOPs to do the decryption. Then moving on to the product teams, we had a similar setup, right? So we had KH releases, and then XYZ is any product team that you needed. In GitHub, we used GitHub templates. We had a template for product teams, and they essentially just cloned the template and then made the tweaks to deploy their workloads. Very similar again, they were leveraging customize, same directory structure. They had their non-environment specific configuration. So here's an example of them deploying the account processor. They've got some environment variables that they want in every single one of their clusters, but they've also got a bunch of other things like default memory limits, etc., etc. But what you'll notice is that there's no tag. So by default, you have to specify the version of the thing that you want to deploy into the next environment, right? It's all too easy if we allow you to be able to set 1.7.0 here. The next cluster that gets spun up is going to get 1.7.0, and everyone's like, well, we're on like 120. Why are we at 1.7.0? So then we have the environment specific config, where we essentially have the diff, and we're going to kind of get onto that image bit in a little while about what that actually looks like. There's a lot of stuff to kind of unpick there, but it's essentially how we allow automatic image upgrades, right? So how do we deploy version 1.2 in Sandbox and deploy it automatically to development and then further on to production? Again, very similar to customization, we're just doing that kind of customized patch there. So you would have noticed just a second ago that there was this block in the configuration that we wanted for the environment. And we can see here that we've got the semvar of the image and also the tag. And then you've got this kind of gobbledygook at the bottom that has like a bunch of JSON in the comment. So how this works in Flux is you have to set an image repository. And the image repository is essentially just a location and how frequently you want to poll that image repository. And then you have an image policy. So the image policy is very similar. It's saying what image repository do I want to go to? So I want to go to podinfo, and then what policy do I want to use to be able to choose the set of tags that I care about. So this is only going to choose 5.0.1 all the way to 5.0. something. Then you have an image update automation. So essentially once you've upgraded your image and Flux has seen a new tag, what do you want to do with it? So in this instance, we're going to do a git commit, we're going to do it to the main branch, here's the author and here's the template. So we're going to be able to say in Git exactly when we made the change and when we upgraded from version 1.1 to version 1.2. These are the comment blocks that you have available to you. So it's policy, image policy, then the policy namespace, essentially where that policy lives, alongside the policy name, and you can choose the tag there if you want to. So here's an example of a Helm release that has an image repository that we want to do automatic image upgrades to on the tag 5.0.0. Behind the scenes, it doesn't really matter what the image policy is. The whole point is that we can change the image policy as we want, but you don't change this comment, right? So in staging and production, the image policy behind the scenes actually looked different, but from a developer's perspective, they didn't really need to know. They were just concentrating on making sure that this was configured correctly. Right, and there's a load of YAML, right, behind the scenes to be able to do automatic image upgrades, right? I showed you there 4 different pieces of YAML. So really, like, stop using Kubernetes manifest and just put everything into a Helm chart. Once we've bundled everything into a Helm chart, we've got this contract where we know now that every application team are going to deploy their workloads using this Helm chart. They have a contract that they are adhered to, and they have the ability to do image upgrades or not do image upgrades at all if they want to. Right, so it's all about, and to Derek's point really, creating those contracts between the platform that they're going to deploy the workloads to and the way that they're going to deploy them. Then we can talk about continuous integration. I'm going to kind of spin through this relatively quickly. So they were using Concourse at the time, not my choice. That's what they wanted. There's no problem with that. We just wanted to make this flow and process as streamlined as we possibly could. So they built with dev-semantic version. It went to the image registry. Flux is seeing that. We patched the Helm release for their application. Flux is actually doing a kubectl apply rather than us as a human. We then write that back to Git. And lo and behold, now inside the Git repository, you can see that we've upgraded from version 0.1.8 to 0.1.9, and the time that it was done, and the person that did it, right? So we've got an audited way of being able to show how changes are being deployed through our Kubernetes clusters, right? That's pretty awesome. Once we showed this in a demo, everyone was like, wow, this is amazing. Like, can you roll the whole thing to production as fast as you possibly can? But when we're deploying between environments, right, there's this important thing called testing, which as an application developer, you need to care about. As a platform engineer, we just kind of ignored it. But we actually need to perform testing in a consistent fashion. So we had this script, right, that said wait for update. And now, because we're deploying all of the workloads from a common Helm chart, we know the label taxonomy of how these things get deployed. So all you need to specify is the name of the application and the version that you're currently deploying. And this wait script is just going to sit there in a for loop and just constantly keep going round and round, a while loop, and continuously keep going round and round and round until you have the number of workloads that you've specified for the application that you care about. Once we've got that far, we then can consume and start testing because we know that the workloads in that cluster are exactly the ones that you want and are currently running. And then to go to the next environment, you just re-tag the image with UAT and kind of rinse and repeat the whole thing, round and round and round. Simples, right? Once we've got this process for a couple of applications, it's just a case of rolling it all the way through all of the product teams, and we just get the ability to be able to automatically do this stuff. Well, then someone came and said, what about Kubernetes changes? Right? You've talked to me about how application developers can easily deploy and upgrade their images, but what about all this other Kubernetes stuff? This is an interesting kind of quote, right? So as in platform engineering, you're just going to YOLO upgrade it. But there's also a bunch of release notes that you should probably read. For any of you that are familiar with Kubernetes, in 1.16, they deprecated a bunch of stuff. And if you didn't make the necessary changes to your applications, the next time you deployed, nothing worked, nothing got deployed. So we had to have this way in which we could kind of YOLO upgrade the Kubernetes cluster, but also make sure that we weren't going to break the application developers' pipelines because we didn't want to be the bad guys again. So one of the things that we used was Pluto. So Pluto is a deprecation checker, essentially. So you take your set of YAML files and you say, I'm running version 1.17 of Kubernetes, run all of my YAML files against all of the deprecated 1.17 versions and print me back what's wrong. If it was wrong, we weren't going to merge the change. If it was correct, we would merge the change, and we knew that it would work on the new cluster. Similarly, we had kube conformance. So we allowed the the application developers to create their own Helm charts, but sometimes they weren't 100% sure of what they were doing, and they would misconfigure something, which is perfectly normal. We all do that. So we needed a way of stopping them from deploying these changes to Kubernetes and then calling and shouting to platform engineering saying, it's not working, it's all your fault, why have you done something wrong? Well, the more kind of guardrails we can put in place in CI, they're familiar with CI, right? The more guardrails we can put in, the easier it is for them to come to us and say, look, my CI job is failing, what's going on? Right, and we gradually made these more and more complicated when we added more and more compliance. We started with things very, really boring and straightforward, and then we added in all of the compliance things that was on a spreadsheet, and everyone just did loads of ticks and had to go to 5 different people and ask them what they were doing. We put those all in code and we codified the lot. Then we had a GitHub action that was essentially, the Helm release is kind of a high level abstraction in Flux, and essentially says, this is the Helm chart, these are the values, go and deploy the thing. But when you're just, all of your GitHub files is essentially just Helm releases, you're not really deploying Helm releases. Underneath the covers, you're actually deploying the Helm chart with a set of values. So there's a Flux GitHub action that was responsible for taking the Helm chart, unextracting it, passing in the new values that you'd specified, and then essentially running a set of scripts against it. Because those are the things that the application developers are really deploying. So if we've got more confidence there, by the time it actually gets to the Kubernetes cluster, hopefully 9 times out of 10 it's going to work. If it gets there and it doesn't work, they're only coming to one team, and that's the platform engineering team. Once we had this in the way of working, and we rolled it through with a couple of product teams, we had the ability to be able to roll it out with a lot of product teams, right? Because product team A was talking to product team B during the onboarding process, and they kind of via osmosis, everybody kind of got the flow of how everything was going to work. Then we did customize this, but we'll kind of skip over that. So how did we do the reliance and make it consistent? So we talked about the fact that we were going to do everything in Terraform, we were going to put the workloads on top, and we were going to start with K8s releases platform. Then we're going to point that at a certain repository, at a certain branch, this one being the master branch, at a certain directory. Once we do that, everything starts to come up, right? So we've got the K8s releases platform, that's going to deploy K8s releases corp, where hopefully you're making all your money. K8s releases secrets, K8s releases Kafka topics, right? It's getting a little bit boring now, but these are different teams that are responsible for doing different things, right, within the organization. And then Istio resources, because everybody has to deploy a service mesh, otherwise companies are not doing anything. And then that was at some directory and environment prefix, right? And if you imagine when I left, this just got horizontally longer because more and more teams were getting onboarded, right? But the pattern in which these things and these clusters get reconciled and kind of resurrected like a phoenix essentially was consistent. So the paradigm was consistent, and any new joiner that started was just leveraging documentation and leveraging pull requests to see how they could add applications and workloads to the Kubernetes cluster. There was a lot less questions that were happening. Then we deployed this, which was brings back bad memories, but essentially Chaos Cube's job is to randomly deploy or delete a pod or a set of pods from your Kubernetes cluster over time. So we started this with a couple of applications a couple of times a week, and then we actually ended up doing this in production, right? Because one of the things that we would always get into the argument with developers specifically was, well, guys, you need to be able to run this as multiple replicas in production. Well, I can't. Well, you're going to have to. Why? Because like this could happen. So what we would do is we would target their application and only their application, and then work with them to make sure and get them to understand why it was important to be able to expect failure, right? And we would do incidents and we'd do blue-green days, and we'd use this tool and we'd kind of make it more aggressive, less aggressive. We'd do it over certain periods of time. But this was really getting us into a situation whereby when there was an incident, we were hoping that 9 times out of 10, the developers could kind of fix it themselves and take that burden a little bit off of the platform team. And then we also repaved every 30 to 60 days. So by repaved, I mean like kubectl delete nodes, all the nodes disappear, all the new set of nodes come back up. So no nodes lasted longer than 60 days. When I joined, they had nodes that were 579 days old, and had had multiple upgrades done to them, and there was people SSHing onto the machines and putting all kinds of stuff. Right, there's no consistency there. So the ability for us to repave gave us more confidence that if we needed to do an upgrade or we needed to be able to rebuild production, we knew that we could handle it, and we knew that the process and paradigm actually worked. Done, right? Mission accomplished. We've done the whole thing. We've given them what they wanted. Can we now finally give them the answer to the question? Well, it turns out that there was still a bunch of problems, right? It's not all golden path. This happened quite frequently, right? So there's like a number of different ways that your workload can't run, and over time, we got to a situation whereby the developers would understand what these types of things meant, right? And we had, if you remember back to where we had the notification controller, we wrote our own custom notification controller that when these types of issues happened, it would take them to a Confluence page that would explain to them why it was happening, and then they would have the ability to be able to fix it, right? So we would expect these failures to constantly keep happening, but as long as we had them documented, they had a place to go in order to be able to figure out what was going wrong. And then this was the classic one, because I told them that it was only ever one YAML file that they'd ever have to deal with. But actually what happened is this, right? There's just tons of YAML absolutely everywhere, and in multiple different repositories, looking slightly different, but it's the same language and the same way of doing things, right? So if they can understand one repository, hopefully they can understand the other one. And then I personally got a lot of this. So like, what are you lot doing? You're taking a little bit of time building out this platform. Can you please explain to me, like, you've got this thing called Flux and it kind of does some magic behind the scenes, but I honestly don't know what you're doing. So it was really about using that enablement team to be the ambassadors and push out, and those were the ones that went on stages like this and talked about how we were doing secrets, how we were doing Kafka topics, how we were doing network policies. And it really drove the adoption of change and allowed the new platform engineers or the new developers to be able to come in and just kind of continue on with the pattern and paradigm that we constructed. But the technology is the easy part, right? The people are actually the hard part. How do you get people on your side? Why are they over there doing all the cool stuff and I'm over here trying to look after the cluster that's got 500 and something year old nodes? Or why do I need to care about GitOps? Like, I don't care, like, just let me just kubectl apply from concourse, like, what's the problem? And it's really about bringing those people together and kind of putting an arm around their shoulder and saying to them, look, here's how you do it currently and here's all the issues that we have. And actually, if you just embrace this new way of doing it, here's the kind of success that you can have. And if you do that with one product team, the other product teams kind of just follow along because these guys are shipping like constantly and you're shipping like maybe once or twice a week. And they want to be in this cool gang, but they're over there in the not so cool gang, and then everyone's like, well, I want to be over here. So there's a blessing and a curse with this, right, with regards to GitOps. This is one blessing, that you end up spending all night trying to work out how you can do absolutely everything in Kubernetes, for better or for worse. And she's over there thinking that you're probably talking about and thinking about other girls. But really what I'm talking about is this, right? If GitHub goes down, everything kind of stops. So GitOps is great until this happens, right? So you do have to have the break glass. How am I going to handle when Git's not working or GitHub's down? What's your way out of that situation? So the main takeaways really are, by the time that I left, we were averaging about 104 releases to production per week. Previously, that wasn't even like 3, to give you an example of kind of the journey that we went on. We could cluster rebuild in 20 minutes. We did it multiple times. We did a massive repaving, where instead of repaving the nodes, we repaved the whole entire AWS account. We just completely destroyed it and rebuilt it. And then the developers were spending 75% less time on operations and actually what they should be doing, which is building features and functionality and bringing business value, right? Not worrying about how they're going to deploy their workloads to the next cluster. That's all from me. Okay, just curious, how many contracts did you do before landing the one in the example? From a cube, I don't know who, hands up who answered this, and I can speak to you kind of directly. Or if you've left, I'll just speak to all of you. So how many contracts before? This was the first time I'd ever deployed Flux, ever, was this client. But it was really about, that enablement team was so important because once we had that enablement team, we had different people with different voices that had, like via osmosis, would go into their different teams and kind of say, look, this is the way we're going to do things moving forward.